Fourth problem of the homework, we get a 500 Newton force applied to the plate as shown. Let's determine equivalent system first. An equivalent force coupled system at B. That means I want to replace this force by a force applied in here and a couple moment that can go this way or this way, depending on the force. Now, basically what we're saying is we need to take this force of 500 newtons and place it right here. When we make this translation of forces, we will create something like this, a moment in this same point. That's the one thing that we want to obtain. So the translation of the force, easy, we just draw it somewhere else. The one thing that will actually make some complications or the not, let's say, the hard part of the task is to determine what's going to be the moment that we create with that translation. So as we have done before, the moment, let's say at B, which is the part where we actually want to translate the force, it's going to be my force times a distance. However, that force, it's better if we decompose it into a force that goes vertical and a force that goes horizontal. If that's the case, we already have the distance y and the distance x. Distance y and distance x we will use in combination with my force y and my force x to create the moment. So my moment is going to be created by moment B1 plus moment B2, where moment B1 is going to be distance y, force x, moment B2, it's going to be distance x, force y. Since we already know the distances, we got to calculate the forces. So force y, we got an inclination of 30 degrees about the vertical. That means force y can be calculated as 500 newtons times cosine of 30 degrees. Force x, 500 newtons times sine of 30 degrees. For the force x, we'll get a 250 Newton force. For the force y, we'll have 433.01 Newton force. Having those values already, just go and replace them in here. Distance y, 175 millimeters, which it's the same as 0.175 meters, times force x, which is 250 newtons. Then distance x, which is 300 millimeters, that's actually 0.3 meters, times 433.01 newtons. The result, the moment B1, it's going to be given as 43.75 newtons meters. The moment B2 is going to be given as 129.903 newtons meters. What is going to be the sense of that motion? Well, we're combining a distance x with a force that goes down. That means this force will actually create a motion like this, negative counterclock. And we have a force x combined with a distance y, that means it's pushing it right here. That's going to create a moment like this, positive. So the one that includes the force y is negative. The one that includes the force x, positive. If we add them together to obtain the moment about B, we will get 86.163 newtons meters negative, since the negative is actually bigger. There we have the result for part A. Now, well, actually the result would be to draw it right here. So I will take my force of 500 newtons to this position. Erase the one that's with this. And we know there's going to be a moment clockwise of 86.153 newtons meters. That's the answer.